Okay, cool. So I guess welcome back from the midterm. I hope you are not too damaged by that. It seems some of you might. Uh, I hope the other classes midterm are going okay. So I know that a few of you are also like taking other midterms. So definitely good luck with all the midterms you're taking right now. Today we will do a few things. The first thing I want you to go over is, hey, we haven't touched x86 in a while, so let's do a quick recap so that when Monday rolls around, it's not too unfamiliar. Basically, before we do a review last week, and before you all do a midterm, I'm sure right now by this point you kind of forgot about a few things already that we talked about prior to that. The first thing I want to cover today is a bit manipulation. Just basically, again, this is probably the third or the fourth time I said this. You can build any logic using and or not. So be prepared in the assignment to do it. Basically, you can actually use and or tilde, which means it's a not. Left shift, right shift to do many things, and assignment 3 will actually ask you to do exactly that. Then we talk about instruction set architecture, which is basically define list of command, similar to how an English word is. Basically, you say some word. The audience will know what is the meaning of that word, right? Uh, and then there's another part, which is the microarchitecture, which is essentially the actual hardware on a computer out of circuits that would do what the ISA, the language, the word tells them to do. So when you buy a microprocessor, when you buy a computer, actually, it essentially just consists of ISA plus microarchitecture. That's it. That's what you get when you buy a desktop. Until you install Linux or Windows, essentially that machine that sits next that you bought is just ISA plus microarchitecture, and that's it. Uh, But with the advances software in compiler in the operating systems as well as in programming language, it allows us not to use zero and ones. You don't have to use punch card to program a computer like the computer back in the 1960 or 1950, or even the computer you saw from the imitation game, right, from the movie where you saw them actually do that circuit switching where you plug in certain wire on a computer and they will spin and they will produce results. You don't have to do that anymore. The act of switching all those wires are now programmable. You actually write a program to switch those wires for you. Right? That's basically what what your program is doing. It's just doing all those switching wires in real time, really quickly. All right. And then on Monday, we'll talk a lot more about instructions, especially in the x86 instructions. Basically, these are the most basic elements of interface between computer and human on software and hardware. Uh, there are two main big components. There's operands, which tells what instruction you are telling the computer to do. Is it an add, subtract, multiply, jump, or and or load something from the memory, store something from memory, and opcode, which is, I mean, my bad. Opcode is the instruction, and operand is what do you do with instruction? Do you write this into certain register files? Uh, for example, in here, if you say add R0, R1, and R2, R0, R1s, and R2s are the operands, the object in the sentence. The operators, the verb, is add. Right? So basically, you add what is what you do. You assign the value R1 plus R2 into R0. That's one example of a really simple ISA. On the x86 ISA, it will be a different syntax. But at the end of the day, they achieve the same goal, something that you can program. Uh, in general, what goes into the ISA are instructions. Obviously, you have opcodes, you have addressing mode, you have data type, you have the instruction type, the instruction format, register, and condition code. Will cover all these things on Monday. You also have the specification of how you want to access the memory. How does your virtual address, when you do malloc and you got some value back, what do they mean? It will tell how the address space, which is a number of unique locations on your DRAM, is assigned to different programs. It talks about addressability. Are you accessing things in a bit granularity? Similar to how your in class exercise 6 is, basically every time you look at that index, those are in bits. Is it in the byte granularity, which is similar to char star, right? So think of it this way. This is in class 6. This is a char star. This is the like a GCC, like a modern GCC, 64-bit GCC int star. And this is something like a float, like a double, the double basically. So that would cover 8 bytes. So this is 64-bit word. Right. So it tells you what when I add the index to that address, do I go by 1 bit? Do I go by one byte? Do I go by 4 bytes, or do I go by 8 bytes? The alignment, which is basically how you would align this word into different bytes. We'll cover that in more details in the next lecture. And once we're in module 4, we'll talk about virtual memory management, which is actually something pretty magical, where you don't have, when you call malloc, you don't have to care about where that thing is in your DRAM. You just got an address and you just work with it. These are things that are not going to be covered in this class. These are more advanced things like calls, interrupt, exception handling. We actually will cover that a little bit toward the end of module 3. And then things like access control, I'll talk quickly about that when we talk about virtual memory. And then you have used things like I/O from the C language when you need to access a file, but we're not going to talk about how that works through the ISA. I'm not going to ask you to write a program in x86 to read a file. Those are not easy. I'm not going to ask you to do thread management. Those will be in the OS class, or if say I'm trying to see if I can push something like parallel programming class. So those might involve thread management. Power and thermal management, we're not going to really talk about this until you are like learning the advanced architecture class, which is basically graduate level, master and PhD level class, but ISA can actually save power. You can do certain things to save power. And then at the end of the day, no need to memorize all these things. Each ISA has their own manual that you can refer to, and that you can actually use it as a reference when you program something in assembly. That's it for the recap of what I want you to kind of like, okay, we are coming back to assembly. The next thing I want to talk about is the midterm overview. So any burning question from the midterm that you want to ask right now that I can cover? Because basically what I plan for us to do today is pick one of the question, the main question from the midterm. I have the link that is basically an online editor where everyone can go in, modify the code, and I will make you collaboratively working on that code. And I'll kind of like gradually giving you hints and fix it along the way. And hopefully that's a good exercise for everyone here to kind of like, okay, this is how you would write a maze solver. But yeah, any questions from the midterm? Because basically, after I have time to kind of like put a solution in a nice format, I'll post it. Will it be curved? Yes, exactly. Depending on how the grade looks, I typically curve my exam. I will never curve down. I would always curve up. You are not even sure what to ask. So how was the first question? It's pretty open-end. Okay, first part is okay. How about everyone else? So do you find the first part, what might happen? Okay, it took a lot of time to, but completed. Basically, what happened is someone logged onto your machine, and instead of the ls command, right, they are trolling you by changing the rm, which is the remove command, into ls. Basically, you can rename rm. That's one way you can do it. Another way is you can create this thing called symbolic link for remove. So whenever someone type ls, it actually is running rm. Right? So that way, you can kind of like troll your friends if you have sudo access, if you have the root privilege. So this can only be done if you are the root. Why is that the case? Because the command are in this relatively protected area on your computer where you only have to be the root privilege to actually do all these crazy things. So the first part is about the environment variable where it cannot find ls. So it means that the path, this one doesn't contain wherever ls is, right? So it depends on your assumption. If you basically when the way you answer is if you kind of like gauge that okay, I just basically cannot find where ls is, then yeah, you get full credit. Hopefully you have the way to kind of fix it with based on your assumption, right? So these answer correctness will kind of be based on case by case assumption that you put in there. If you don't put any assumption in, I'll just assume the default, which is ls is missing, or the path doesn't have uh, that directory to ls. The second question is, oh, so you want to annotate the slides? All right. So one of you are requesting the annotation, right? So if you want to draw something on here, feel free to just do just uh keep go ahead and do it. All right. So that's for about the first question. Since we're doing the maze anyway, we'll cover that toward the end. How about the last one where we have to do the two-level linked list essentially? Any any questions? And I know about how much I'm aware that it might take you more time than I expected. There'll be a poll that I just sent you. Just put in how much time you have spent so I can like adjust it accordingly. Because I so the problem with like me guessing how much time you would take is I've been working with C for I think 15 years now. This is the first time you see C code. I'm trying my best to like gauge how much time I would have taken if I'm like back then. Uh and it's not always going to be perfect. And the fact that I still got email on like 2 a.m. On that day of the exam, it tells me that okay, this is too much, right? And I would like to address it. The first thing I try is if you have not realized the full credit is at 100 point, but the full score is 120. Basically, you can pick two of the questions. Like, okay, fine, I'm not doing this. So hopefully, the 100%, like the 100 out of 100 is like about the time it should have taken you, which is between like 4 to 5 hours. I'm not sure if that's the case, but that's what I'm hoping for and aiming for. And based on your response on the poll, so that I can basically adjust the final. Okay, so if you get the idea about the last one and you don't know how to execute it properly, you actually, if you put in pseudocode or like this is what I'm trying to do, or like this is the code I'm trying to do. Basically, whenever I grade these exams, not the assignments, right? When I grade these exams, I always read your code. The last thing I do is actually run and see if it compile and execute properly. But then having everything correct, basically between the process of like getting your code up, written out in a way that I know exactly what to do, and then you miss a few steps. You get like partial credit, pretty close to the full credit, to be honest, and I'll see how it goes. I would basically tell you each one of you in detail on like if there are deduction, I'll tell you what's going on. Please give me some time because I need to read your code in detail, and there are like 30 of you. So this might take some time. I want you to be aware of that, but I would read your code, and if it's not syntax like synthetically like basically the syntactic and the syntax like if the syntax is not correct, but I know what you're trying to do, I'm aware it's 24 hours, so I don't going to put too much pressure to get everything perfectly. All right. Also, if you submit, like for example, the test case alone, this is like my edge case and everything that should cover like at least 10 points out of those, like each of those for each those two questions. All right, so now that there's no questions for so far, the last question about the double linked list is essentially it's the same, almost the same as a linked list. But then when you insert to that second level, you need to keep track of the counter, right? That start from 0, 1, and 2. If you have insert this range, like these many elements, you want to make sure you can skip from the 0 elements to like one, like every other 3 elements. And you can use that counter basically to count down on how many elements am I in between, right? And when you have that number, then essentially you can just decide if you want to add that node into the second level or not. The first level behaves the same way as a normal linked list. That's all. And then assumption that I already made to make the insertion easier is the list is sorted. Right? So you just need to compare where do you need to insert, where do you need to delete, and where do you need to do the find because it will keep going up. Right? Uh, so that's for now. So let's go to the link I share on Canvas. Basically, you go to lab edit.com/ERYP, and now I would share my screen here. So can you see the screen with a bunch of code? Go to this link. You can type it in and it will take you to this basically a relatively blank code on how to do MIS. So first of all, this is a collaborative exercise. I don't want to write everything for you. You are going to write the code. I'm going to hint what to do to fix the code. So right now, let me provide you a few hints. There are tricks you can do with this program to make it a little bit simpler. But for the first thing I would like you to put in is how to read the math. Basically, I would like all of you to kind of like work together and see if you can finish this read math. So the tasks are basically the first line, you get dimension, right? Which means that you do the malloc based on the dimension. Okay. This is pretty simple. Read into x, s, y, dx, and dy, right? Basically, you read that, write the value into sx, sy, dx, dy. So the second line, the way you read the second line should be really easy. And then the plus line read yes. All right, can someone take a stab? Write something. I'll correct it. Don't worry. It's not, you don't have to make sure it's like all syntactically correct. I'll give you one more hint. This is what you need to put in. Includes standard library. Otherwise, you cannot read files. And there are like 10 of you, so you can feel free to edit it. Don't feel bad if it's not correct. I'm here. I'm gonna like fix what you write. Okay, good. You are reading one number, right? Oh, actually, this is a nice one. So I'm not sure who is writing this printing 2D mesh. It's great. Basically, this
ครับ มีครับ
yeah,
มีครับ
that's a great helper function. It allows when you want to debug something, it allows a much more convenient method that you can see. Okay, this is my maze. Let me give you one more hint. This is one thing that I added. The reason why I add this is basically you have a two-dimensional pointer. And it's not as convenient, right? Because essentially what you want to do is you want to print ARR, right? X and Y. Right? But you have these two pointers. So one thing we can do is to return ARR plus X plus Y here, right? You then get the integer value of the maze. It can be whether it's visited or not. It can be whether it's a 1 or 0 or not. But then you can just say read coordinate x, y, AR, right? And then you get the integer value of that. So great. That is
อาจารย์แล้วสแกนแบบนี้อะครับ
which one? Can you highlight so I know where you are?
I type it in
So
read me
that is basically so you need to do fscanf, right? So it's the same thing here. Since your friend already write it out, so I'm gonna cut and paste it here, right? It's the same thing. You just need to make sure that you have the file pointer, which I define up there, named input, right? So you just put in input over here. Then that would scan everything that you need to scan. So this is the first line. Then the next task that you need to do is to allocate space for our mess, right? Default. then you scan the maze. Right. Because you have the array right here. That array, basically, at the end of the day, you have to read it. I have one more question. How can you tell that whether you visited something or not? The easy way to do that is not the most efficient way, but this is the easy way. Is to have another array that say visited, right? And the integer value can be something like how many steps did I take? You can even make it easier to store coordinate and do this, right? But let's do integer value for now. And you can assume 1 means you have visited it, 0 means you have not visited it, right? Another task you need to do is to implement the queue. But as our basically, let's skip this part, right? Because assignment to ask you to do it. But just make sure that there will be a function that say int up, DQ. And then void NQ. So in this case, it's a coordinate. Good. Oops, why do I put in pointers? All right, this is awesome. Any one of you have any questions in the meantime? I am monitoring the chat, so you can ask the question on the chat as well. I would type it out. And if my keyboard hitting is too loud, let me know. I have a mechanical keyboard that's obnoxiously loud. And I'm not sorry for that. I love it. So any one of you have any questions about this part? This is basically the correct way to read the input.
So when I try to do this, I found out that when I scan for the maze part, right, or the one zero in each line, it just became one single integer. So need to read by character instead. So it's separate.
Yeah, exactly. So you can do this. This one way you can do it. Read one character at a time. Alternatively, with this alternative option is what I was planning. We can use getC for that. getC basically read one character. Another easier alternative is getS. getS would read the entire line, but because your target is essentially a array of character, get s is actually it's not easier to be honest because it's an array of integer. My bad. So just use get c, and you convert the character into an integer value. So over here, one thing that you forgot is to say input equal f open. Line 45. Yeah, sure. Basically, this is you need to allocate a space for two-dimensional arrays, right? It means that you have to do both the x direction and the y direction. Well, the x direction, the horizontal direction, and the vertical direction. Over here, we pick the vertical direction first. So you then first allocate the pointer for each row, the pointer to represent the starting point of each row. Let me draw a blank presentation over here. Can you see my slide? Like a blank slide here. Oh, a blank like monitor. Let's see how good I am at doing this. So this is your array, right? It's a two-dimensional thing. This is conceptually what you want. Okay. Not too bad, I guess. So what you need to do to allocate this is essentially you need individual rows, right? You need first individual rows that you can access. And dot, 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 right? What is this thing? It's an array, right? It's an array, which is basically, this is int star, right? This is an array of integer. So the first thing you need is you need the array of int star, which is over here on the y dimension. So the first thing you need to do is to allocate the starting point of every single arrays over here, right here. So that's why you first need to malloc. Okay, my handwriting on a mouse is bad, but somehow it's readable. It's actually a little bit more readable than my own handwriting. Malloc for the y dimension. And what should be the data type, the size of that you put in? Can someone answer me that? So do I do size of int or int star? For the y dimension, which is this thing. Do I do int or int star? Int star. Yeah, perfect. Yep. So you put in int star, and the result here return to array. So you put in malloc here. Malloc size of int star multiplied by y dimension, which is, yeah, keep this just in case. Which is exactly this line, right? You basically allocate the column wide pointers, and then for each line here, each array in the row, you then need to malloc the x dimension. And once you finish the malloc, you can read the file, which is input, right? So don't forget to do this, and don't forget to close the file. All right, where are we? So we are, I think, stuck here for a while. But this look correct. So you have something like this, it's basically it's I think 10 point already, right? If you finish implementing the queue, which I'm not going to write here, I believe that's 15 points. So by now it's 25 out of 40. Now you just need to solve the maze. Solve maze is a little bit tricky. So can someone start something? First of all, we have this uh, visited, right? What I would do here is to also initialize visited as well. And because I want to make sure that I initialize everything to 0, I can use calloc instead of malloc. Actually, this dimension is malloc is fine. And then over here, oops. First of all, visited is declared already, so I don't have to do install store again. And then visited y. Here would be x dimension, and you can do calloc because you want to make sure I some hint. You want to make sure you initialize everything there to 0. Okay, good. So this is another good helper function. Basically, you check if you can walk there. If it's a 0, which means it's a wall, you don't want to go there. So let me give you a hint. This is what I would do. I would solve maze starting x, starting y, right? And then I put in a maze. I would leave it here first. I'm not gonna tell you what type I want to return, but this is a helper function. Uh, Basically, this tell me I want to go solving my math starting from this point. Then what I need to do here is basically I'll say if, oh my bad, if visited x and y, return, right? If you already visited that node, you return something. Else, it means that it's a new node. You have not visited yet. The first thing you might want to do, well, you now visited the node. So visited x, y equals 1. Right? You there. And then, what do you do? So based on the description of my exam, right? The first thing you do here is you enqueue neighbor, right? But do you want to enqueue everywhere? No, right? Because basically you need to for basically for something so this is loop through our neighbor node. How many neighbor nodes you can have? 4, right? So how many times should I loop this? 4. Oh, actually, let's not loop this. I don't think you need to loop it. It's easier to do it this way. Just do it 4 times. Check for each safe. Right? Why? Oops. I always hit the page down. My bad. So this is the x plus 1. That's the east direction. So if it is safe, you end kill, and you do the same thing 4 times. X, y plus 1, x minus 1, y, and then x, y minus 1. What direction is this? X and y plus 1. Y plus 1, you go down, right? Y plus 1, you go down in the area. So this is the south direction. X minus 1, you go to the left. So that's the west direction. And y minus 1, you go up. Go up is the north direction. Basically, you check if you can step to those direction. If it is the case, you NQ. Once this is done, what is the next thing we do? So based on the description on the exam, we DQ, right? So you have the coordinate. You call DQ and you put in the coordinate in temp2. So you now get the coordinate of the next thing you want to search. You get the coordinate of the next thing you want to search. What do? You recursively call this function. Yeah, recursion. So you do temp2.x, temp2.y, and then miss. Any questions about this part? Basically, think of it as you go into this function and you expand outward. Every time you are in a coordinate, you put the next neighbor in the queue. And then once you finish putting out the neighbor in the queue, you pick one of that in the FIFO order, first in, first out. So the next time you want to search would be now you search your neighbor. Let me try to visualize it on the slides here. So can you see my blank slide again? So let's say this is your starting point, right? And these are, so this is start. These are the 4 neighbors, and let's say the left part is not safe, is a wall, right? Once you're in start, you just mark this as visited. And then you put 1, 2, and 3. So 1, 2, and 3. go into my queue. Right. So your queue would have now 1, 2, and 3. Right. And how does the recursion work? You now then pick one, right? Pick one here. So you are over here. Get rid of it from the queue because you already visited. Now you mark this as visited as well. Then you search one's neighbor, right, over here. So this is 4, 5, and 6. What do? What happened to my queue? So now, originally, your queue has 1, 2, and 3, right? You DQ 1, so you are left with 2 and 3. The next thing you do is you put in 4, 5, and 6, right? Right here. So when I go through recursively through this, which is the next node? Which is the next coordinate that I'm searching? Is it 2 or is it something from 4, 5, 6? Are you still there? Basically, I DQ, right? So I'm gonna take 2 out. This go out. So now you already visited this. So I'm gonna mark this visited node as left, I guess, left diagonal highlight. So you already visited 1, visited S, visited 2, right? Which means now you have node 7 and 8 in the queue. So 7 and 8 come in here, right? So now you see that from the starting point, you are going to gradually expand outward one step at a time. So this will be the first, second, third, right? Assuming that that's a wall. So you search all the coordinates that take one hop, one single hop to go, followed by all the coordinates that take 2 hops, right? So 4, 5, 5 is here. This is 6. This is 7. This is 8. This would be 9. And this would be 10, right? From 4, 5, 6, 7, 8, 9, 10, do you see that you take 2 steps to get there? 4, 5, 6, 7, 8, 9, 10. Take 2 steps. Then 11, 12, 13, 14, 15, 16. Hopefully you now got the idea. It's kind of really ugly to draw this going forward. 18, 19, 20, 21. So anything from here, anything from 11 to 21, take 3 steps. Basically, this will keep expanding outward until you reach the destination. Once you reach the destination, you know that, okay, I am at the destination. So first of all, going there is possible. The next task is, how do you trace back? How do you trace back to your original? All right. Keep this. So do you understand how this works now? Basically, you recursively put the next coordinate that you want to walk. So you go in order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, based on the level that I did earlier from the slides. What am I missing here? I missed this one, right? If x destination x is x and destination y is y, you return because you are at the destination. Return something. So my question is, how do you get the coordinate? This is what you need to do. Basically, every time you call a function, you know that, okay, this is the path from source to the destination. So you just need to know, okay, this is the steps I'm going, right? And when you do a recursive call, you can just return this. Return submass of the path here. What do I return here? I'm at the destination. Right? Because you already keep track of everything, including the current coordinate. So you just need to return that. How do you call this? Basically, you now put in the current starting point coordinate as the first item in my for start. So you kind of got the idea. And then one more thing you need to do, this is the hard part, and I'm not going to wait too much on the exam for the question, is how would you keep track of all the tasks using dynamic array? So this is the extra credit part where I put in intentionally for this question. If you got to this point where you know that, okay, somehow I need to keep track of the path, this is how I would do it, but it's not fully correct because the way I do malloc is not exactly expanding to all the possible path. In that case, you get essentially 40 out of 50, which is you missing that extra credit part on how to keep track of all the dynamic array, but you'll be fine for the total number of points. Any questions about the maze? Okay. Yeah, that is the easier way. So I have I have that as a like the solution, to be honest. So another possible way is to have another duplicate 2D array, but then inside the 2D array here, the visited, this visited, you can do coordinate, right? Visited and path. You can kind of combine everything in there. That is actually easier. But it's hard to kind of explain and visualize it on PowerPoint without the proper whiteboard and the code. So I was avoiding that. Your suggestion is the method for like how you would solve it. The more efficient way, right? The actually, if you want to think about, okay, how can I be the most efficient? In this case, you don't even need our maze because you can use this as your maze. Basically, a wall can be -1. A path is 0. A path that you have not visited. A coordinate that doesn't contain, like, basically the coordinate that contains itself that has only one element. A wall means a null pointer. And then you can build the array using that information, and you know exactly where the wall are, and you know exactly where the unvisited node are, because you then will see the pointer with only one items in there. It will be more memory efficient because you only have to build one array, in one 2D array. Any other questions so once I finish grading for every one of you, I'll put in the solution. So that way you can go and look at the code. Okay, this is how you might solve it. Uh, and I'm pretty comfortable releasing the solution because I'm sure if I teach system skill again, I'll keep changing the questions. Uh, so I want to make sure you understand how the code works. Uh, The solution should be out sometime in the next, I don't know, 2 or 3 weeks, depending on when I finish grading. I want to prioritize grading first because there are 30 of you, and I want to make sure you know your feedback before that. I'm going to think feedback is more important. But if I somehow manage to like clean up the code and everything and have the solution up, I would just put it there on Canvas. All right. So let's switch back to our lecture here. And we are pretty much done. So can you please go to the announcement from the class website and fill in the poll? So that's the link. I really would appreciate if you tell me how things been going for this class. This is the first all online class where I didn't even get a chance to see who you are, right? There's no like, hey, this is the first class. I go in and introduce myself to everyone, and I'm like more familiar with like, okay, who is working with what, who are kind of friends and tends to like work in groups. Uh, it's not that I did not know when I go into like a live classroom because you can kind of tell. Right now it's all online, right? So I know that the interaction between me and you will be a lot less, right? I try my best to reply to emails, and I know that sometimes sometimes it takes me a few days, sometimes it takes me a few minutes. It kind of still vary. I would like to address it and see if you have additional comments about the class that I can use and integrate to make the class better. For example, one of you give me a comment about this particular lecture saying, hey, it would be great if we can do a programming, basically a live programming alongside the midterm instead of just like writing how you would solve it, right? So overnight, I was trying to find a way to do that. And it seems like the only editor that we can use right now is Collab Edit. If you are aware of any other like website that we can write code together and compile C code at the same time as well, please do let me know. Because I feel like this is another way that we can make this effective as well. I don't want to just type things on my monitor and compile it and run it on my machine because otherwise you don't get to type, right? I want to make sure you get to type your own code over here and I look at what you are typing. So if you have a suggestion or anything related to the class, please let me know before, like maybe by this week, by next week, I will integrate those feedback and improve the class. And the reason why I do it now is I want to make sure that I incorporate your own comments before the end of the class because otherwise you put in comments, it doesn't matter to your life, right? So I want to make sure that whatever you put in, I try my best to address it. If you say, okay, the class content is too hard, nope, I'm not gonna fix that. I would make sure I try to get it such that you have easier time understanding the material. I'm not gonna make the material easier for you, but I'll try to make sure and see other things I can do to help the understanding of that, to help you understand the material better, or to find a way to find a way to give you feedback. And one of a few of you also suggest that I should monitor Discord, which I would actually do. But so for Discord, I am trying to work and see if there if I can create the channel. So I now know that I need to ping Ajahn Sansan to basically get my profile to become the moderator, like the instructor. Then that means I can now create the channel. Once I have the channel, it's much easier for me to keep track of things. So I'm working on it, right? So once that's done, I'll announce it on the announcement. To be honest, super swamped until Saturday, but once Sunday roll around, I'll try to get that done as soon as the next week roll come in. So that's all for the feedback discussion. And that's it. Basically now, if you have questions about in-class exercises or assignment 2 or anything basically on a midterm or whatever, feel free to ask them right now. We have like 40-50 minutes left. I'll stop recording for now and feel free to ask me questions.